Okay, for question 10.1.1, they wanted you to prove that x2 is the diameter of the smaller circle. So guys, what I did there is I looked at TR, that they told us is the diameter of the bigger circle, right? And we know that the diameter subtends a 90-degree angle, right? And that's what I did there. And then, oops. Oh, and then because we have parallel lines here, do we remember how co-interior angles work? Co-interior angles, the C shape, they add up to 180, right? So if that is 90 degrees, M2 will also be 90 degrees because of co-interior angles. Or you could have said M1 is 90 because of corresponding angles, the F shape, and then M2 is 90 angles on a triangle. And then guys, if you have that M2 is a 90-degree angle, you have that H2 subtends a 90-degree angle. The only way for that to happen is if it is a diameter.
That I'm stable. So wait, yeah,
Okay, that's fine. There we go. So that is what I wrote there. You can mark it here. All right, and for this one, I put tick in, and then I see that for the rest I didn't. Yeah, I'll add it in. Oh, yes, yeah, I'm sure you want to. Yeah, there's sort of written TQR. Yes, that's right. And forward. Yeah, I think that. 180. So guys, I wrote T1 plus Q2, but you could have just written TQR, hey? It's the same thing. That's fine. Okay, for the next one, you had to prove similarity here in order to prove that RT was equal to that. So I looked across at all these things. I said, okay, RTQ is a triangle and RT2 is also, no, RTQ, sorry. RTQ and RTQ is a triangle there. So I looked at those two. So this is RQ times RQ, right? So I matched one RQ with that one and one RQ with that one. So I looked at those two triangles. So just quickly, RTQ and RTQ. RTQ is the big one. And then RTQ is the one here at the bottom. So did you guys notice the tan chords there? Q3 will be equal to angle T. And then I said we have a 90-degree angle here, right? Which is given. And we proved that this is 90 degrees in the previous question. So I went to that one. And then the third thing. How many marks was this one? I don't know those questions in that. 6 more. Okay, so guys, often with these ones, they give you a mark for identifying which triangles you're actually working in because it wasn't given. So that's 4, and then 5, and then 6. They probably won't give you a mark for this because this was given, right? But you have to write that. They'll do like negative marking. You didn't actually write that, they'll write it. That's quite nice, 6 marks in that question. Right. Okay, then let me just check what came next. Okay, so 10.2 was the more difficult one, which many of you guys did actually figure out. So I'll just show you here what I wrote. They gave us the length of MH and PQ. So I filled those in. MH was 14 and PQ was the square root of 604. So guys, you had to use midpoint theorem for this, which is something that you learned in grade 10. You also did the proof for midpoint theorem in grade 10, but that's actually not examinable. Okay, so you don't have to do the proof, so no stress about that, but you do have to be able to use it. So how midpoint theorem works is that if you have a line from the midpoint of one side to the midpoint of another side, then that line is parallel to the third side, which was given, but also that line connecting, guys, stop talking to you, very distracting. That line joining the two midpoints is half the length of the third side. So if they're telling us that this line is 14, then QR would have to be 28. But before you can use that, you first have to prove that M and S actually both are midpoints of these two sides. Now guys, TR is the diameter, right? And S is the center. So it doesn't make sense that S is definitely the midpoint of this line. So if you wanted to, you could actually fill in on your diagram that those two lines are equal. Right? They're both radius. And then for M, to show that M is the midpoint of TQ, that's a little bit more difficult. I filled in this 90-degree angle here, right, from the very first question. Now, guys, you remember the theorem, line from center perpendicular to chord, which we don't really use all that often, but it says that if you have a line, so I'm looking at the big circle, all right? If you have a line from the center of the circle perpendicular to a chord, so to TQ, that line is in bisects the chord, cuts the chord in half. So that means that TM and NQ will have to be equal. All right, so M is the midpoint of TQ. You have to state that line from center perpendicular to chord, and then S is the midpoint of TR because it's the center. Okay, so that's the first thing that I wrote there. Oh, is it? So my calculations are wrong. Okay. 640. Okay, thanks for that. So this is 640. You guys can tell me what the values are. Oh, and then 12. Okay. So 640. So 144 and then 12. That's simpler. And then this is going to be 28 squared over 12. Which is what? And then half of that is 30. Yeah. Just quickly, what's this answer here? Thank you. Yes?
Is the same as the bigger term?
Yes.
So is so is MS a chord for the bigger term?
Yes. No, it's not a chord. So MS is a chord for the smaller circle, but it's a line from the center of the bigger circle to a chord of the bigger circle. So TQ is the chord that I'm looking at. Okay, guys, so from that, if you have that is 14, that one is going to be 28, and the reason is just midpoint theorem. Okay, you run it right, it's just midpoint theorem, that's what you need to write. Yes. You will lose marks, yeah. So instead of writing S is midpoint of TR, you could have written TS equals SR and TM equals NQ, but in words like that is just. Okay, and even I suppose this line wasn't really necessary. I just wrote it so that you can follow nicely step by step what I was doing. But guys, you definitely will get a mark for writing M as the midpoint of TQ, right, from center perpendicular to chord. Or some other statement that comes down to M being the midpoint. Okay, so if you wrote TM is equal to MQ, well, that is fine. Therefore, QR is 28 units, midpoint theorem. So then from that, once you now have a length of QR, I'm just going to go back to the picture quickly. You can now actually calculate PR, right? Using Pythagoras. So this is a right angle triangle. So from there, and then also I'll fix that now. This is 12 units there. And now this statement, guys, is what we got from, or what we had to prove in the previous question. Which again, even if you couldn't prove it, you are allowed to use it. Okay, so please remember that. In the previous question, we proved that RT is equal to RQ squared, which we now know is 28 squared, over RP, which we now calculated as 12. And that helps us because they've asked for the radius, right? But RT is the diameter. So you can use this as a formula to calculate your diameter and then halve it to get the length of your radius. You could have also done this in one step. You could have said radius equals RT over 2 or something like that and just done a calculation. This was 6 marks, hey? So that will probably be 1, 2, and then there we go. Yes, that will be the one that will So guys, if you compare these 6 marks to the previous 6 marks, right? The same number of marks, but this one was much more difficult. I marked this question and the guys did not know. Some people got it, but it was definitely like lots of lines through it out. Okay. So mid-choice theorem, guys, if you can't remember that, you must maybe go look back in your grade 10 workbooks. Why would you not? I actually do. Yes. Oh, you saw that one. There we go. Or you can just Google it. Or you can go watch my grade 10 lessons. Okay, guys, for this one, the 2020, how was this one? I can't remember now. Was it right? It's just those, the very last question was also definitely problem solving. So let's quickly look at this one. Yes, yeah, but it's on the next page. Prove that if VGM is a cyclic quad, this one here, right? Guys, I used converse exterior angle of the cyclic quad because it was given that M2 is 90 degrees, right? And DE is the diameter of the circle, so B2 is also going to be 90. So there you have that the exterior angle is equal to the opposite interior. Or you could have said an extra step you could have put in that M1 is 90 degrees because of angle on a straight line. And then because that one is 90 and that one is 90, then opposite angles will add up to 180. Then your reason would have been converse of angles. Opposite angle of cyclical. Sorry, my course just went across. Had to wait for them to come back in. All right, but that's what I wrote. That would have been the shortest way, but if you did it in the other way, that's just fine. So B2 is 90 degrees, angle in semicircle. So therefore M2 is equal to B2. So guys, if you can see that it's a 3-mark question, then I suggest writing that down. Okay, because also they did actually give a mark for stating that. And then the 3rd mark is for that reason. Or you could have said M1 is equal to 90 degrees, angles on a straight line, in which case that would have been the 2nd mark, right? Instead of that one. That would have been your 2nd mark, and then your reason would have been, so you would have to write that statement again, but then the reason would be converse of angles of so when do you converse? Is it only between the yeah. So if it is a cyclic quad, you don't use the word convex. If you're proving that it's a cyclic quad, you do. And guys, these are actually the reasons that we are very strict on at the end of the year. If the word converse is not there for this, then you don't get that mark. And also if you write the word converse when it shouldn't be there. Okay, are we fine with that first one, guys? Okay, then the next one, you had to prove that B3 was equal to F1. So what did I do there? I said B3 is equal to D2. Do we agree with tangent theorem there? They told us that AC is a tangent, right? So B3 is equal to D2. And then I said that D2 is equal to F1 because of exterior angle on the cyclic quad. Now, remember, if you prove that this is a cyclic quad, following on from that, you can use properties of the cyclic quad here. So guys, F1, see it's the side of the cyclic quad that's been extended, and on the outside, F1 is an exterior angle of that cyclic quad. So it has to be equal to the opposite interior angle. So you always look at the one next to it, which is F4, and then the angle opposite that one. Or you could have said that F4 will be 180 minus F1, or something like that, because of angles on a straight line, and then you could use opposite angles on the side of the like that. Okay, that is a little bit fine. So that's what I wrote there. You can also look at the next one. It was also quite a simple similarity proof there. To prove that those two triangles are similar, the two triangles were given. And guys, like I said, if they've given it to you with the similarity statement, right, they're actually telling you which angles must be equal. So if you look at me listing my three angles, right, for CDB and then CDE, I listed them in the same order as the letters, right? Because now I know obviously C will have to be equal to C. That was a common angle. But now you know you need to try and figure out, is there a way to prove that D1 is going to be equal to that angle? Or that B1 is going to be equal to E? Because this has to be the order. That's the order that they gave us. So both angles would have to be equal to that. Okay, sometimes it will be easier than other times. Yeah.
Just in, ordering the D1 plus D2. What about the D then 1 plus 2?
That's actually wrong.
Wrong.
Yeah, it's wrong. Yes, yes. Yeah. To check that I'm doing. D2 also equal to C. So C. And then oh no, because C is not in the circle. It has to be at the circumference. They can't be out. Yes. Okay, guys, are we finding that one? 3 marks. Okay, then 10.2.1. Oh, the other one is actually on that side. So 10.2.1, they asked you, they gave you some more information. They said because it's further given that CD is 2 and DE is 6. We now need to find the length of BC. So guys, you can see I just pulled that in. You can ignore this 4 here. That was from later on. So CD was 2 and DE was 6. That's what they gave us there. They wanted us to find the length of BC. Here is 4, but you see why that is just now. Now guys, again, if you're stuck, always look at what you proved in the previous question. Alright, because more often than not, that is what you need to use. So, in the previous question, what did we do? We proved that these two triangles are similar. So, I did my cross cases. Again, you can do all 3 fractions if you want, that's fine. But I just did the 2 that I could tell I would have to use. Now, we can see here that BC comes up twice. But that's fine, that's what we're trying to solve. Okay, so it's okay that we have BC twice. Now CE, important here, CE was not given, but we have that is 2 and that is 6, so does it make sense that CE is 8, right? So CE was 8 and then CD was 2. So then you could do like a cross multiplication thing, right? This BC you multiply off on the other side, which will give you 20, and this 8 will go to that side, which is then 16. All right, so BC is then 4 units. Now, I'm quite curious to know if anyone was able to get the answer of the next one. So what did you get? What was your final answer? We'll look now, we'll see now. Okay, so guys, what I then did for the next one, yes. So for the next one, I got 2,68. Yeah, check with my brain. 36 square root of 36 plus 5. Maybe it's not the same now. Yes, that's what I got. Okay, guys, so I'll just show you my working here. Okay, so what I did was I worked with what were we trying to find DB, all right? So DB, so I thought, okay, let's again do frog faces and work with DB because we had a lot of the values of those lengths at this point, right? We calculated that BC was 4, we have that EC was 8. So yeah, I decided, and I think this is also what you started off doing, right? So basically I wrote BE in terms of DB. I'll show you now why that was Useful. I wrote BE in terms of BE. Guys, we need to remember that this was actually a right angle triangle. All right, and I actually used that in this case to help me. So we have that BC was 4 and we have that is 8. All right, so I used that in my fractions. Let me just show you again. DB over BE, that's from my frog faces, is equal to BC over EC. And then I filled in BC was 4 and EC was 8. All right, that's what I did there. Then I simplified that to a half. Okay. And then I simplified it from there. Now, guys, in hindsight, it would have been better if I put BE at the top, but because I was trying to solve with BB, that's why I put it at the top to start with. All right, so I wrote BE then as Q times DB. I remember from marking this, you also would have gotten the first mark if you said that DB was a half of BE. So basically for expressing one of those two sides in terms of the other. Okay, then I looked at and that's the reason why I thought to do that is because I wanted to work with pi back here, because I wanted to find this side. And I realized I don't have B, right? I don't have this leg. So let me express this one in terms of one of the other sides. Okay, and that's what I came up with. So BE, I wrote as 2 times DB, right? So then I said DB squared is going to be hypotenuse squared minus that one squared, right? Or the other way around, which is how I wrote it. That's the hypotenuse squared, BE squared is equal to the sum of the other two sides squared, right? Remember that's how pi that works. So that's 36. Here I now replace BE with 2 times DB. Right, so that I don't have a DB and a BE, because I don't know what BE is. Yeah. Then if you square that, you get 4 times DB squared. Then I added those together, 5 DB squared. You're working here, obviously could have been slightly different from mine, that's fine. All right. And then you get DB squared on its own, I divided by 5, and then I square it. So guys, 4 marks is not a lot of marks for all this work, but it's because it's a problem solving question. They knew that not everyone would be able to do it, so they rather made the mark a little bit. This was another one that was close to it. It's not one answer. So from this statement here, so if DB over BE is 1 over 2, then BE is going to have to be double B. So I work with this ratio. Any questions on this one? In the next one, this was actually from last year's paper, and I also marked this one, question 11.2. The complaint that people had was that the diagram was very busy. They said that the diagram probably should have been drawn a bit bigger, and there was just a lot going on, so it was a bit confusing. So hopefully this year they won't give you a diagram that has busy. That's the feedback we sent through to the department. Can I go on to the next one? Are we ready? Okay, so there we go. That was the picture. You can see, if you're actually filling everything in, there's a lot there. Okay, so hopefully this year they'll be more mindful of that. First thing they wanted us to prove that K4 is equal to NML. Most people could do this one from what I can remember. So I went via S1. So I said, okay, K4 is equal to S1 because it's time forward. Right, they told us that is the time. So K4 is equal to S1 because it's time forward. And then we have an F shape here, guys. Those two lines are parallel. So because of that F shape, S1 will be equal to NML corresponding angle. Okay, so those were the 4 marks there. It was statement reason. Just make sure that you do always end off with what they ask you to prove. Then the next one was it just a 1 mark question? Okay. To show, was it 2, 1? Okay. Now guys, obviously if it's a 1 mark question, then you know that you have to use what you proved in the previous one, right? If you had to make any other kind of, saying this angle is equal to this or something, it would have been at 2. Okay, so 1 mark. So that means that we're looking at this shape that I highlighted, right? K in M L over there. Now K4, we just proved that that is equal to N M L in the previous question. So K4 is an exterior angle of the cyclic quad, and then N M L is the opposite interior angle. So you would have to say again converse for that one. Yeah. 1 more. We'll find the last one. I'm going to post this whole document, all the notes on the whole section this afternoon because we've done it now. So if you're missing something, then you can go check there. All right, then they wanted us to prove similarity. Now, the marking for this question was the beta by equation. I'll explain to you now how we marked it. There were two pairs of angles that you had to prove equal. And then the third pair was obviously angles on a triangle. So I think if this M3 equals M3, this was your first pair, you would have gotten just the 1 mark for it. Okay, so M3 equals M3 was your first mark or 1 mark for that. Now guys, I'm using the cyclic quad to prove this. I'm going to go up quickly. N3 equal to M3. So we notice that N3 and M3 are both subtended by KL. M3 and M3. Right? They're both subtended by KL. So guys, in the way that it's drawn, obviously M3 is not at the circumference of this circle and M3 also not. So why can I use angles in same segment for this if they're not at the circumference? Because K in ML is a cyclic quad, right? Meaning that you could actually draw a circle going through those 4 points. And the M3 and the M3 would be points or angles at the circumference of that circle. Yeah. And then I can do all of that. But the first one I see is also in N is equal to S2, yes. And then in R2 I didn't have to order yes, yeah. So that was the thing with this question. There were multiple ways of doing it. Okay. So I'll go through your method as well. Okay, but are we finding the M3 and the M3, guys? Being angles and pancakes. Okay. So that was my second line. Okay. For the first one, what did I do? I said R1 is equal to M2. So Fatima, you said our equal chords equal angles. Which chords are equal now? R1 and K2. Oh yes, R1 and K2. So how did we know that this one is equal to that one? R2, sorry. R1 and R2. This one. So you're saying this one is equal to K2 and R2. At least I have an undo button. Okay, so you're saying that these two are this one in M are equal because of angle. I'm not sure, but like it's K2. From which chord? From K. So KL was those two, right?
Yeah.
But now I'm looking for K2 and L2. I think there was a way of, but it has to come from the same port. You see, K2 is coming from MS and L2 from MN. I remember that there was a way, but I wouldn't say I was in the same segment. I think there's probably an extra. The thing is, the bow tie shape has to come from the same port. It can't be a chord here and like a chord there. So K2 is subtended by this one. And L2 is subtended by that. See? Yeah. What? On this one now, are you talking about the cyclic plot? The actual, so, yeah, but see now, ST is not a chord. It has to go, it would have to be KS. You see, ST is not a chord. Okay. But I do remember there was a way, there was something like that. Okay, guys, what? All right, let's look at this one. This is the one that was weird to me. So for proving that L1 is equal to K2, so Fatima, I did actually prove those to equal, but you had to do an in-between step. And yes, I remember if you just proved it like this, then you didn't get any mark. So you have to show that L1 was equal to M2. Okay, L1 is equal to M2 because they're both subtended by Kn. Kn subtends L1 and M2, right? Yeah. So that was the first segment. But then M2 is equal to, what was it now again? M2 is equal to K2 because of that Z shape, alternate angles. You see, this diagram definitely is there's too much stuff happening here. So M2 was equal to K2. So because of that, L1 is equal to K2. Now guys, obviously you could have written L1 equals M2 first, or maybe you wrote M2 equals K2 first. Whichever pair you proved equal first, you got a mark for, and then a mark for the reason. And then the second pair, you got a mark that was statement and reason. So basically it was 3 marks for getting to this conclusion that L1 is equal to K2, but you have to go via M2. L2, this is like the same thing. Maybe L2 is, it's not. L2 is in the same segment as K1. Is they both subtended by M2. But it's like, this is like this one. Yeah. So I'm not like that. So it's K1. Yeah. But like like L2, and then but not the thing is the bow tie shape has to come from the same line, and L2 is coming from M and K2. But yeah, guys, it's both there. If you guys have that in this topic, okay. M3 because I'm trying Yeah. We don't know what. And just like so that would only work if those actually. Okay, guys. Then this one. Okay, next one was you had to work with the ratio that they gave you, which was this, which many people swap around. Lots of people use it the wrong way around. So from your similar triangles, which guys, again, if you couldn't prove them similar, you can use your calculator from there, right? They wanted us to find the length of KS. So again, you could have written all three fractions, that's fine. So I said KS over KL is equal to SM over KN. Similar triangles, you could have added the third fraction, or third fraction rather, sorry, to the side. Now I use this formula just to get this ratio, guys, because then I saw, okay, now I have SM over KN, which are the two sides that are mentioned here, right, in this ratio that they gave us. They gave us 3KN is equal to 4SM. So I wanted to rewrite this ratio as SM over KN so that I can sub it in. Okay, so I rewrote the ratio there. I wanted SM at the top, meaning KN must be at the bottom here. So then that 4 must go to the bottom here. Okay. It was 1 mark for doing that, for actually getting that ratio in that form. So then KS over KL, which they told us was 12 there, is then equal to 3 over 4, which is coming from there. And then you could just say 3 over 4 times 12, sorry. So that was basically working with your similarity statement and the ratio that they gave you here to get to the values. And then the last one, again, not well answered at all. They told you now, if it is further given that NL is 16, LS is 13, and KN is 8, determine with reasons the length of LT. So guys, now, what did I do here? Now they gave me the length of KN, so I realized I can now actually find the length of SM using this ratio that they gave me up here, right? Because they told me that KN is 8. There we go, KN is 8. So that's what I did there. So I just used that ratio which they gave us in the previous question. KN was 8, so to get the 8 out from the bottom, we times it, so SM was 6. And in many cases, this was the mark that people got in this question. So calculating SM. Then we could use crop theorems. I don't know if you guys want to look out for that. Okay, so let's go back up quickly. I'm looking at, sure, now I must keep my words about it. I'm looking at, sorry, crop theorem is these two lines that are parallel, right? What are we trying to find? We're trying to find the length of LT, okay? So, I feel like I need another color, but then, okay, I want LT there. We have that LN is 16. So if I want to use crop theorem, I'm looking at those two lines that are parallel, right? LT over 16 will be equal to 13 over 19. And because I calculated that SM is 6, I know that that whole side will be 9. Right? Does that make sense? I'll show you again quickly. I'm trying to find LT, so I'm looking at this triangle here. I'm going to use crop theorem. LT over the whole side, because that's the length that they gave me, 16, is equal to this length, 13, which they also gave me, over the whole length, which is 13 plus 6. And that's the 6 that we calculated, so 19. Let me just show you the calculation again. There we go. Again, guys, this is a reason that they are very strict on. If this is not there, you don't have to solve. Yeah, go to the parallel line. Okay. How are we feeling? I don't want to feel panicked because of these questions that we looked at now, they were difficult, right? They're not all gonna be like this. Okay, finance. Let's go, let's go.
Yeah.
Let's go. Finance. Did it take us 15 minutes? There are 14 minutes. Let me just clarify. And it's not 13. Yeah.